Hey, Taoping Alliance Math and History, and we are going to experiment with the parabolas. So in the past few videos, we have been learning about what the vertex of a parabola is, what parabolas are in the first place, and how we can graph a parabola. But we're going to be using an equation that we can use to experiment with the parabolas and explain why we see those on a graph and why they look like that. So, the equations we're going to be using today is quadratic standard form. So, a quadratic standard form equation is ax squared plus bx plus c. So, your ax squared would be your x squared. Your bx would be your normal x, or one variable as x. Your c is just your normal number. Here's an example. We can write the equation 3x squared, that goes in the first part, plus 2x, that is the second part, and 3, which is the third part. That is quadratic standard form. But what we are going to be doing today is experimenting with a new kind of equation. We're going to use ax squared plus c, which means we are going to get rid of the bx. So we're going to be using equations such as y equals 3x and y equals 3x plus 9, and more of that. Let's start comparing. On the blue side, we have an equation of y equals 3x squared. On the opponent side, the green side, we have y equals 3x squared, but we're going to use that as a negative 3x squared. So, what we're going to be doing is calculating the a value, the c value, and the vertex, because we're using it in this form. We are going to compare the two. Now let's graph them. Wow, would you look at that? When you saw on the graph, we have the blue equation facing up, while the green equation facing completely down. So let's measure the values. So the a value for the blue equation is going to be a positive 3. However, on the green equation, it's negative 3 because we focus on the number right here, right in front of the x. Another thing is the c values are both zeros because y equals 3x squared and y equals negative 3x squared does not have a c value. There's no plus 9, plus 10, plus 7, whatever it is. Now the vertex. The vertex is actually where the point where the parabolas are at the curves. So right there, we can write that as a point as 0, 0 for blue, and 0, 0 for green, because they all meet at 0, 0. And what we can figure out is, if you have a parabola with a positive coefficient in front of the x squared, you will always be able to get a parabola that faces up. If you have an equation with y equals negative as a coefficient before the x squared, you will always be able to get a parabola that's facing down. So positive up, negative down. That is our first finding. Let's see round 2. Okay, so here is round 2. On the blue side, we have y equals x squared. On the green side, however, we have y equals x squared plus 3. So this round is a little bit different because we have an equation that doesn't have a c, but on the other one, it does have a c. So let's graph them out. Okay, so what we saw there is we saw the blue one and the green one going up, which means that they're both positive parabolas because they have a positive coefficient in front of them. There's an invisible 1 in front of them. When we look at the A, C, and vertex, the A value is going to be 1 because there's an invisible 1. For the other one, it's the same thing, 1, because there's an invisible 1. The C value is going to be a little bit different. The C value for this one is 0, because y equals x squared does not have the C value implemented. For the green one, however, the C value is 3. Or, if we use the y-intercept, it strikes at 0.3 as a point on the graph. The vertex is also a bit different. The vertex for blue is still going to be 0, because that is where the end of the curve is. For the green one, however, the vertex is 0.3 as a point, or 0,3 I mean, because that is where the green one ends, because 0 is the blue one. So what we can find out in round 2 is having a value of C is going to change where the end point of the curve for the parabola is on the y-intercept. Let's move on to the final last round, round 3. Okay, so here is round 3. But the only difference with round 3 is we added a third opponent. So blue and green are not only playing with each other, but they are also having a battle royale with the red opponent. So, with the green side, we're going to have an equation of y equals 2x squared. On the green side, we're going to have an equation of just y equals x squared. On the red side, we're going to have an equation of y is going to equal 1 over half x squared. So we're going to see some sort of competition between the three of them. Let's graph it. Okay, so what we saw is we saw that the red equation was on the bottom. We also saw the next one was the green equation right on top of it. And the blue one was very on the top. Let's see why that happens. We can all see right here that all of the parabolas are a positive because they end up going straight up. Let's start analyzing. So the blue side, the A value is going to be 2 because the number right here in front of the x squared. With the green value, it's going to be 1 because x squared is the same thing as 1x squared. With the red equation, or the red side, we have 1 over 2 as a fraction, as the a value in front of x squared. The c value for the blue side is 0 because there's nothing there. The same thing with green, and the same thing with red. Now, let's look at the vertex. When we look at the vertex, the point is 0, 0, because it ends at 0, 0. The same thing goes with the green and the red one as well. What we just found out in round 3 is every time we saw the a value change, the first number right in front of the x squared. And when you change that, it can depend on how wide you want your parabola to be. The bigger the coefficient in front of the x squared, the less wider the parabola is, because 1/2 over x squared is the widest, following x squared and 2x squared. If you want a very wide parabola, you might want to use one with a small coefficient. If you want to have a very narrow parabola, you will probably want to have a large whole number right in front of the x squared. So here's another example how changing the a value affects how wide you want your parabola to be. And that is the end of round 3. These experiments with the parabolas were actually pretty interesting, because when you affect one thing, another thing gets affected. And that concludes the video. I hope this video has helped you understand how parabolas can change their equation and their shape and looks on a graph. Thank you for watching Tao Ping Airlines Math Industry. Like and subscribe!